Okay, Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. And today we are going to discuss a few more past year questions for chapter reaction kinetics. So we start with question number 8. Right. So on the screen at question number 8, hydrogen peroxide H2O2 reacts with potassium iodide in the presence of hydrochloric acid. The chemical equation are given below. And then the rate equation for the reaction is rate equal to K concentration of H2O2 times I minus. Okay. Then if you look at the statement, it says H2O2 reacts with potassium iodide and HCl. However, in the chemical equation given, there are no KiOH plus or HCl, but instead they put I minus and H plus. So basically, this I minus is referring to Ki, while H plus is referring to HCl. And then from the rate equation, okay, rate equal to K concentration of H2O2 times with I minus. So from this, what we can conclude is H2O2 is the power of 1, I minus also with the power of 1, while H plus is the power of 0. So in other words, H2O2 is first order, I minus also first order, but H plus is 0 order. So the question said state the order of the reaction with respect to Ki and HCl and then the overall order. Okay, so Ki equal to first order, HCl 0 order. And then overall is equal to the sum of each order for each reactant. So 1 plus 1 plus 0, so it should be 2, which means second order. Okay, so this is for the first part in question number 8A. Now let's look at the second part of question 8A. Question 8A. Right? Table 2 shows the experimental results obtained for the above reaction. Predict the values of G, H, and J and then calculate the rate constant. If the reaction is carried out at higher temperature, would the value of rate constant change? So predict the values. This is the first question. Calculate the rate constant. Second equation. And then would the value of rate constant change? This is the third question. Okay. So for this kind of question, it is better to recap the characteristic of each order. So let's recap. For zero order, let's spell out zero order. Okay. So if you do any changes towards concentration of reactant, the value of rate will remain constant. Any changes meaning if you double the concentration or probably you reduce the concentration by half, the rate will always stay constant. That is the characteristic of zero order. First order. Okay. For first order, if we double the concentration of the reactant, alright, square bracket represent concentration. Rate will be 2, double is 2, power of 1. Kenapa 1? This one is referring to the order. 1 meaning first order lah. Okay. If we triple the concentration of reactant, then rate will be 3 power of 1. Again, 1 is referring to the order. If we halve the concentration of our reactant, then rate will be 1 over 2 power of 1. So for the last one, meaning if we halve the concentration of the reactant, rate will be reduced by half. Okay, so that is the characteristic of first order. And then lastly, characteristic for second order. So first, let's double the concentration. So when we double the concentration of reactant, rate will be 2 power of 2, meaning increase four times. Okay, these two up here referring to second order. Then if we triple the concentration, that will means rate will be triple 3 power of 2 because of second order. Then the rate increased by a factor of 9. What happens if we halve the concentration? If we halve the concentration of reactant, and then rate will be 1 over 2 power of 2, which means rate will reduce one over 4. So in other words, if we halve the concentration of the reactant, the rate will be 1/4 from the original rate ataupun the comparison lah. Okay, so this is the characteristic of zero, first and second order. Zero order meaning you do anything towards the concentration, rate will always be the same. First order will follow your what did you do towards the concentration of your reactant. If you double, rate also double. If you triple the concentration, rate also triple. If you reduce by 1/3, rate also reduce by 1/3. Okay. However, for second order, dia ada sedikit extra lah. You double, dia double square. 2 times 2 power of 2. If you triple, then it triple square. That's why dia punya graph, kalau ingat graph untuk second order, dia akan jadi seperti ini. Dia curve macam ni. Tapi curve saya tu lajak lah tu. Macam tu lah dia ni curve. Dia curve ke atas. Tapi tak ada melengkung ke belakang. Salah. Right, so this is question number 8A. Tak ada lagi rupanya. Okay, we don't want this one. The question actually asking for this part. Okay, we need to predict the value of G, H, and J. So let's first we label this one as experiment 1, this one as experiment 2. Ingat pula. Experiment 1, experiment 2, experiment 3, and last one J, experiment 4. Okay. Since only experiment 1 have all the values, so we are going to use experiment 1 to compare with experiment 2, 3, and 4. Okay, so let's start with first one. So we compare experiment 1 and experiment 2. So let's look first at the rate. Rate between 1 and 2, from 1 to experiment 2, rate double. So rate has double. Rate has double. Okay. And then the order of reaction for H2O2 is 1. This one is 0 order. I minus is 1. Okay, remember 0 order have no effect. So kita boleh close kat sini. Close our eyes. Abaikan terus, ignore. Untuk H2O2, okay, dia nak cari G, so unknown. Concentration I minus remain constant. So rate double, but concentration I minus is constant. So this will only lead to one answer, meaning concentration of H2O2 has double. Meaning 0.1 times 2 is 0.2 molar. Okay, so finish the first part. So tahu. Next, kita nak compare antara experiment 2 and experiment 3 and experiment 1. Kita nak cari H. Okay. Experiment 1 we compare with experiment 3. Okay. 1 and 3. So dia punya rate constant. Rate is constant. H2O2 constant. Concentration H2O2 constant. I minus, since rate constant, yang ni semua constant, that will mean concentration of I minus also constant, which is equal to 0.1 molar. Betul. Okay, and then last one J. So comparison between experiment 4 and experiment 1. So I just translate. Experiment 4 compare with experiment 1. Okay. So rate unknown sebab rate yang kita nak cari. So ni tak tahu lagi macam mana. Okay. Concentration of H2O2 double. So concentration H2O2 double. So bila double, should be rate akan increase by a factor of 2. Double concentration rate times 2. And then I minus also double. Concentration I minus double. Meaning rate also will increase another factor by 2. So a total factor is 4. So conclusion, rate will be, so 1 exponent negative 4 times 4 will be 4 exponent negative 4 unit molarity per second. molarity per second. So ini increase by a factor of 4. Okay, so that one should be the end. Is it? No. Finish number 1. Number 2, calculate the rate constant. So first we write the rate law. Rate equal to K concentration of H2O2 and concentration of I minus. Okay, so if you get the value of G, H and J, so basically you can use any of the experiment to find the value of rate constant. However, if you worried that your value might be wrong, just use experiment 1, because in experiment 1 all the values are given. So lebih selamat kat situ. Okay. So 1, 0.1, 0.1. So rate is 1 exponent negative 4 equal to K. H2O2 is 0.1. I minus also 0.1. Therefore K equal to 1 exponent negative 2. Molarity minus 1 S minus 1. Lebih lah. Okay. Kenapa dapat M minus 1 S minus 1? Because the overall order is second order. Okay, if you unsure with the unit, okay, let's check. Unit for rate macam kat atas ni, MS minus 1. So MS minus 1 equal to, this is the rate constant, we need to find out what is the unit. And then molarity of H2O2 and molarity of I minus. So K equal to MS minus 1 divided by M times another M. So we can cancel out this M and this M, or this one pulang. And the remaining will be M, one yang atas, minus 1 and second minus 1. Okay. That is for the rate constant. And then number 3, if the reaction is carried out at a higher temperature, would the value of the rate constant change? This one I think I already answered in question number 4B. It's okay lah. Okay. By using Arrhenius equation, by using K equal to A E negative EA over RT, this is the Arrhenius equation. Okay. When temperature is increased, the term A pula, the term P exponent, sorry, power of EA over RT will be larger. Thus, the value of rate constant K will increase. Alright, so settle for the first part in question number 8. Right, so that's it. And then question number 8B. Okay, for number 8B, latent first. Okay. The rate constant for the reaction below is 0.0234 per second at 400 degrees Celsius and 0.75 per second at 500 degrees Celsius. Calculate the EA in kilojoule per mole for this reaction. So here we have, so we label this one like this. This one as K1, this one is T1, and then this is K2 and T2. Remember, temperature must be converted into Kelvin. So plus 273.15. So we have K1, K2, T1, T2. So the only formula in mind is ln K1 over K2 equal to EA over R in bracket 1 over T2 minus 1 over T1. Okay. Where R equal to 8.314 joule per mole per Kelvin. Okay. So substitute the value. K1 0.0234, K2 0.750 equal to EA. We need to find out. Our R is 8.314, 1 over T2, 500 plus 273, so 527, 723. Eh, 273 kan? 273 meaning 773.15. And then T1 56, so 673.15. Okay, then just substitute and calculate the value. So what I have calculated before, check first. Okay, so EA will be 150.031 if you get the value from your calculator, which means this is in joule per mole. Okay. Kenapa joule? Sebab R tadi dalam joule. Question wants in kilojoule, so your answer must be divided by 1000. So it will be 154.03 kg per mole. Okay, so that is the first part, and then draw a label energy profile diagram for the reaction and then calculate EA for the reverse reaction. Okay, energy profile diagram, so kena ada pasti Y pasti X. Okay, pasti Y tinggi dia berapa? So this is potential energy. Unit in kilojoule. Pasti X is reaction progress. Reaction progress. Okay. The delta H is negative, so exothermic. So this is our reactant. Then we have our hill for EA. This is the product. Okay, seems like my EA is larger than our delta H. Delta H 110, EA 150, slightly tinggi. Begitu. So increasekan saya punya EA, and then delta H jangan terlalu besar. Okay. So bila you punya nilai EA lebih besar, if your value for EA is larger than delta H, make sure this part, your EA is bigger than your delta H. (110) negative because of exothermic reaction. This is EA kilojoule. Okay, so tak perlu skill sangat, cuma just visually you nampak EA is larger than your delta H. Delta E pula. Delta H. Sorry. Okay. Then we put in our reactant NO2 and N2O gas plus NO dia nombor apa ni? Nombor 8. Okay. Gas to produce N2 and NO2. N2 gas and NO2 gas. Okay. And then the question asks you to calculate the EA for reverse reaction. So when you reverse or when we reverse our reaction, okay, so the product will become the reactant. So the EA must from the level of this reactant all the way up to our top of the hill. Bukit yang tinggi itulah. So this will be our EA reverse. So from visual alone, you can see that the value of EA should be the total of 150 plus 110. Because the reverse reaction is endothermic. Forward one, negative, exo. Reverse one should be endo. So it will be 150 plus 110 equal to 260. 0.03 kalau you nak ambil 0.03 ni. Okay, so unit dia still lagi kJ per mole. Okay. Alright, so that should be the end of question number 8. Ini boleh tulis kat bawah lah. Dia kata. Right, number 9. Number 9, keluarlah soalannya. Number 9. Okay. Number 9, table 1 shows the data obtained from the following isomerization reaction at temperature of 25 degrees Celsius. Reactant A to produce reactant B. Okay, so given experiment 1, 2, 3, but the rate of reaction for experiment 3 is unknown, so we cannot use experiment 3, just use experiment 1 and 2. Number 1, determine the order. So should be in your mind, you're going to use experiment 2 divided by experiment 1. Right, so number 1. Experiment 2 divided by experiment 1. Can you do 1 divided by 2? Yes, you can. Experiment 1 divided by experiment 2 also can. Up to you. Right, so experiment 2, 12 exponent negative 5 divided by 1, 3 exponent negative 5 equal to rate constant K times rate concentration of A 0.5 power of M divided by another K rate constant 0.25 power of M. If somehow you are wondering why I wrote this formula like this, so basically for this part I follow the rate law. Rate equal to rate constant times concentration of A with the power of M. Then repeat experiment 2 divided by experiment 1. Itu je lah. So follow lah yang ni punya structure. Right, 12 divided by 3 will be equal to 4. K and K will be cancelled out. 0.5 divided by 0.25 will be equal to 2. So power of M should be 2. Therefore, the order of reaction is second order with respect to A, reactant A. Okay, so that is for number 1. Number 2, calculate the rate constant. So, using our rate law, rate equal to K concentration of A, the order is 2. Okay, so use any value from experiment 1 or experiment 2 to determine your K. So, this part I'm going to use experiment 2 lah. So, experiment 2 punya nilai. The rate is 12 exponent negative 5 equal to K unknown times with 0.5 to the power of 2. So, K equal to ini bagi yang 0.5 square should be kita akan dapat 4.8 eksponen negatif 4 molarity minus 1 minute minus 1. Because this is the second order. So second order molarity per second. However, in the question give you in minute. So molarity per minute. Dengan guna second semua sekali. Tolong alert dengan unit. Right. Next, number 3. Number 3 asks you to determine the value of Z ataupun Z. Up to you which country you belong. Okay, Malaysia disebut Z. Nah, Z. Okay. Determine the value of Z. Sekejap boleh. Oh, gunilah rate law. Rate equal to K concentration of A squared. Rate yang kita nak cari, so rate ini adalah Z. Rate constant we just calculated 4.8 exponent negative 4 times with A, concentration A at experiment 3 is 1, power of 2, so basically 1 power of 2 is still 1. The value of Z should be the same as negative 4 unit, because this is rate, not rate constant, so just molarity minute minus 1. Beza K ni rate constant, Z cuma rate sahaja. So molarity per minute, rate constant, molarity minus 1, minute minus 1. Okay, kita tukar kat situ. Okay, so that is for number 9A. Now let's look at question number 9B. Okay, 9B pun saya buat page baru. 9B. Number 9B. The following reaction has an activation energy of 120 kilojoule. Given the chemical equation 2NO2 to produce 2NO and O2, the first one, define activation energy. Definition. EA is the minimum energy required to required by siapa? Required by reactant in order to initiate chemical reaction. Okay. Number 2. Draw and label energy profile diagram for the above reaction. Number 3. Determine the EA for the reverse reaction. I think this question similar to previous one, number 8B. 9B, 8B taklah sama semua dia, more or less similar. Okay. So, apalah, buat je lah kan. Dah diminta, kita buat. Label, this is part C, Y, and then this is X-axis. This is Y. Y we label as potential energy. Unit in kilojoule. Part CX is reaction progress. Then what happened? Label the reactant product. Given to you negative, so exothermic. Exothermic. EA dah bagi belum? 120. So EA dia still lagi besar daripada dia punya delta H. So this is our reactant. So EA tinggi sikit. Produk boleh lah begitu je. So reactant is 2NO2. Product is 2NO2. So labelkan. So from the level of reactant towards your top of the hill, this is EA forward, which equal to 120 kilojoule. And then from your level of product to your reactant, the energy difference we call as delta H, which equal to negative 113 kilojoule. And the question asks for the reverse reaction. Again, when we do reverse reaction, the product will become our reactant. Reactant for reverse reaction. R. R meaning reverse. So EA for reverse reaction is from the level of reactant yang baru, all the way to the top of the hill. So daripada sini sampailah puncak yang tertinggi ni. This is EA. So this is EA for reverse. To reverse lah. So how do we calculate EA for reverse? Okay, number 3. So determine the activation energy for the reverse reaction. So EA reverse is equal to positive 113 plus 120. So 1 plus 1 is 2, 1 plus 2, 3 kilojoule per mole. Okay. Why I use positive here but negative here? Because the forward reaction is exothermic, meaning reverse reaction is endo. From bottom to the top, dia perlukan tenaga. So dia must absorb positive 113. Remember, negative sign here only represent energy is being released ataupun heat is released. In other words, exothermic reaction. Forward exo patah balik jadi endo. Always opposite to each other. Best nombor 9. Okay. So that's all for question number 9. Now kita proceed dengan question number 10. 10. Ini semua graf. Dah graf. Right, number 10. A. The decomposition of hydrogen peroxide. Decomposition of hydrogen peroxide is according to the following equation. The rate constant of 2.32 molar H2O2 is 7.3 exponent negative 4 second minus 1. Plot a graph based on the data, and then from the plot, determine the order and half-life. Nampak ada sedikit tak guna pada soalan ni. Kenapa saya cakap macam tu? Because dia bagi dia punya rate constant, unit dia S-1. So, bila S-1 should be first order. However, dia kejam kat sini, dia kata from the plot. Daripada plot graph kita, from there we need to determine the order. Determine the order and then half-life. So, walaupun kita boleh tentukan order daripada unit, but the question said from the plot, determine the order and half-life of the reaction. So, terpaksalah guna graph untuk tentukan order. Question dah kasih kan, baru guna je tu, lagi senang. Tak apalah, saja dia nak bagi markah aku kat korang. Ini saya nak buat graf A versus T, lebih senang. Kita masukkan graf kosong dulu. Dan terus sikit. Okay, boleh lah ni. Pattern. So, title. Saya nak buat graf untuk concentration of H2O2 versus ataupun against time in second. Okay. Nak buat paksi ni yang lambat ni. Saya tekan sikit, senang saya nak buat garis. Anggap sampai sini. Sampai sini, boleh tak? Apa saya nak lurus bagi lurus. Okay, lurus saja. Lurus satu. Then sini tikul. Dia kena buat pasti baru tahu. Tak je. Ini anak panah, ini anak panah. Labelkan sini adalah masa, time. Unit dia second. Ini adalah concentration of H2O2. Unit dia molarity. Okay. Concentration 0.25 sampai 2.3. 2.5 lah. Tengok muat tak muat. Harap muat. Malah nak buat lagi sedih ni. (0.25) Kat sini 0. Besarkan sikit. So 0.25 kat sini. Saya ingat pula. Pada line tengah ni tengok juga 0.50 dekat sini, 0.75 kat sini, 1.00 kat sini, 1.25 1.50 1.75 oh 2.0 2.00 2.25 sorry 2.50 right 3000 masa 3000 kan 3,246. Okay, cukup. So, sini 200, 400, 600, 800. Okay. Ni 1K. Dan 1200, 1400, 1600, 1800, okay. 2000, 2200, 2400, 2600, 2800 aku. Ini adalah 3000. Okey. Jom plot. Okay, semalam saya nak lihatin atas. Masa kosong 2.32. 2.32. 2.25. Oh, sekejap. Okay. So, kat sini 0.25 dia perlukan 10 kotak. 0.25 divide by 10. So, satu box kecil ni. Okay, satu box kecil ni equivalent to 0.025. Kemudian yang ni 200 bagi 5. So satu box kecil ni 20. So 40. Ini ke dalam unit molarity, dalam unit second. Okay, satu box ke atas equal to 0.025. Satu box melintang ke tepi ni 40 saat. Okay, kita nak 2.32 calculator. Okay. So 2.32 divided by 0.025 tadi tu. So saya perlukan 92.8 kotak. Itu lebih kurang 93. So kalau kita kat sini 10, 20, 30, 40, 50, 60, 30, 80, 90. 22.8. So 91, 92.3. Ini dah lebih kurang. Okay. Then pada 200 second molarity is 2.01. Itulah senang. 2 dekat sini. Okay. Saat ke 400. So 400 second 1.7. 1.72 divided by 0.025. So saya perlukan 68.8 kotak dalam 69 lah. 68.8. Tak apa kan? Di sini. So 10, 20, 30, 40, 50, 50, 60, 60, 70. 9, so kurang 1. Okay. And then minit ke 600 1.49. 1.49 bagi 0.025 59.6 59.5 tengah-tengah 60 kurangkan setengah 600 dari 60 600 1 2 okay. 10 20 30 40 50 60 so 69 ini dia nak 0.5 60, 59 kan 59.5 lebih kurang lah okay. Selepas 600 120 so 1200 dia nak 0.98 0.98 bagi dengan 0.025 so saya nak 39 kotak lebih kurang 1002 mana ini 39 1, 2, 3 ni 40 kat sini 39 okay. And then 1008 saya nak 0.62 bagi 0.025 so 24.8 25 lah 1008 dia nak 25 so 10, 20, 25 Kemudian pada 3000, 0,5, 3000, 0,5 cm. Okay, masa untuk sambungkan kita punya titik-titik tadi tu. Okay, dia curve, bukannya straight line. Memang betul lah dia first order. Betul. Kalau awak dapat straight line, bermasa awak lukis untuk zero order. So, ada salah lah tu. Memang sepatutnya awak dapat ke... tu yang akhir pula buat hal. Boleh lah. Buruk sikit, tak apalah. Korang buatlah bagi lawa. Kenapa tak lawa lah? Biar saya patah balik. Tak hati, tak hati. Boleh lah. Asal boleh kan. Nampak tak tu? Nampak lah kan curve sikit. Okay lah tu. Jangan kecam. Okay, so dia punya half-life. First half-life, initial concentration 2.32 bagi 2. So, 2.32 bagi 2 is 1.16. 1.16 kita bawa kotak. Bagi dengan 0.025. So, saya nak 46.5 kotak. 46.5. 46.5. So, 10, 20, 30, 40. Ini 45, ini 46. Di tengah 46.5. So 46.5. Atau tidak. Okay. Okay, sini ada ni 800, ada 1, 2, 3. So 3 kotak darab 40 saat. 3, 120. Darab 3, 120. So 120 plus 800. So ini lebih kurang dalam 920 saat. So first T half equal to 920 second. Ini based on graph Kita buat second half life. 2.32 bagi 2, 1/16 tadi. So bagi 2 lagi sekali. 0.58. 0.8 0.025. Banyak ni. 23.2. 23 kotak. 10, 20. 1, 2, 3. 3.2. So mesti lah. So 1, 2, 2 kotak. 2 kotak 40 tambah 40 40. So 1880 kan. So kat sini kita dapat 1880 tolak dengan 920. 1880 tolak 920 960. So kat sini saya dapat lebih kurang 960. So saya punya second half life based on ini. Okay. So my second T half apa ni? ND. My second T half is equal to 960 second. Okay, so kalau saya tukar kepada minit, nampak macam jauh beza kan? Okay. 920 bahagi 60 equal to 15.33 minit. 15.33 minit. 960 bahagi dengan 60, saya dapat 16 minit. Okay, so beza cuma 30 saat. 30 saat ni pejam mata pun lebih 30 saat. Alah, punya yang ni dia kata lama ni. Okay. So just about 30 second different itu sebab saya punya graf tangan tak betul. Nampak dia ada sengit-bengit, ulang ke depan tu, tu salah. Okay. So what we can conclude here, okay, kita punya pastilah first half-life is equal to second half-life. Therefore, reaction is first order reaction. Okay. And then disuruh buat apa? Tentukan half-life. So kita dah dapat gini half-life tadi kat sini daripada graph. So the first half-life is 920, second one is 960. So saya ambil average. So half-life, tapi kalau daripada graph kita tengok yang first half-life is 920. Ambillah 920, 920 second sebab first. Jadi kalau dia mesti range kan. So 920 tambah 964 divide by 2, 940. Lebih kurang lah 92, 94, 96. Masa pun lebih kurang itu. Dia saat ni sekejap. Alright, so ada lagi tak? From the plot determine order and then half-life. Settle this. Okay, seterusnya. Calculate the concentration of H2O2 at 1600 and the percentage of H2O2 decomposed up to 1600. Okay, so disuruh calculate, tapi kita buat dulu method by graph. Okay, kalau kita buat from graph, so 16 saat, 16,000, 1,600 naik sampai sini. So sini kita buat garis tak dulu, saya nak guna ni lah. Ini daripada ini gariskan sampai mana atas bawah tu, tapi mana pula. Zoom sikit. 1,600. Oh, bila terus. 6 sini. Sampai ambil yang atas tu. Nah, pada lain. Angkat je layan ni ya. So, jadi properties bagi dekat lain. Okay. Fitness 3 style. Oh, tak boleh tukar. Buat derivation. Okay, settle. Okay, so lepas kita gariskan ni, kita kira belakang kotak dia. So, dari sini ke 0.05 ada 10 box. So 10 Allah hilang. So 10, 20, 30. Tolak 1, 29. So 29. 29 darab dengan 0.025. So saya dapat 0.325. So daripada graf saya dapat 0.725 molar. Okay. Tapi dia nak calculate, so kena guna formula. Ln concentration of H2O2 power of 0 power, not minus ln H2O2 equal to KT, masukkan nilai ln 2.32, mana datang ni pada saat dia kosong dalam table tadi, itu 2.32 initial. Ln H2O2 kita nak cari equal to K given dalam soalan 7.3 rasanya. Okay. Eksponen negatif 4, masa 1006. Okay, concentration H2O2 equal to 7.3 eksponen negatif 4 times dengan 1600 ln 2.32 tolak answer, lepas tu shift ln answer, dapat 0.7215. Oh, 0.725 dengan 0.7215 tak jauh beza. So kita ni kira betul jugalah, walaupun tangan saya tak lurus, tak cantik gerah, tapi dapatlah lebih kurang sama kan. Okay lah, settle lah tu. Okay, calculate concentration and then percentage of H2O2 decompose. Ini final concentration. Percentage decompose maksudnya yang dah bertukar jadi produk. Okay, percentage of H2O2 yang dah decompose, yang dah bercerai-berai, decompose is equal to yang dah hilang ini, yang tinggal tolak dulu. Okay. So H2O2 concentration H2O2 decompose yang dah bercerai is equal to initial 2.32 tolak dengan 0.725 215. So 2.32 minus 0.7215. So yang dah hilang sebanyak 1.5985 molar. So tukar dalam bentuk percentage. So percentage H2O2 decompose equal to 1.5985 divided by initial 2.32 times 100 untuk percentage. So answer divided by 2.32 times 100, kita dapat 68.9%. Okay, kita jadi bukanlah boleh dekat bawah kan. Okay, B. Alamak, terpadam. Inilah. Terpadam. Yalah, saya tak save lagi. Dia muncul. Baik. Hai. Cuak pula bila dia hilang. Saya nak ni, tak nak. Saya nak ini semuanya. Bismillahirrahmanirrahim. Jenuh kalau hilang, nak ubat balik semua daripada awal. Okay. Last one for number 10B. Both reaction rate and rate constant are temperature dependent. Briefly explain the effect of temperature on reaction rate by using Maxwell-Boltzmann distribution curve. So the effect of temperature towards reaction rate. Temperature on reaction rate. Maxwell-Boltzmann distribution curve. So buatlah graf yang ada curve 2 T1 ada T2 tu kan. So kita buat paksi dia dulu. This is our axis, y dengan x. Boleh lah. Kat ni sikit lah. Sama kait lagi. Ni sikit. Okay. Boleh. Jom label. Kat sini biasanya pasti y is a fraction of molecule. Okay. FR. Fraction. Tak nampak lah PVC. Saya spelling pun cloud. Fraction of molecule having kinetic energy. Dan paksi y biasanya paksi x kita label sebagai kinetic energy. Okay. Buat garisan. Lah nak garis-garis ni dekat atas saya tangan tak lurus ni. Start daripada bawah lah kan. Ini naik, turun, macam tu. Anggap jangan tengok saya punya pakai bengkok tu. Manusia, tak perfect. Ingat kan? Boleh lah. Jangan kecam. Ni T2. Ini T2. Ini tanah tak lawa. Tanah balik lah. Saya nak kuati. Kita try kali kedua. Lawa tak lawa. Kalau tak lawa, biar je lah. Tinggi T1 dan turun. Sama-sama. Okay. Turun balik ni. Okay. Dah baik. Lawa sikit daripada tadi. Jauh lah. Jauh naik. Dia landai sikit. Dia turun. Dia dah. Ni. Macam ni. Jauh sikit daripada tadi. So this is T2. Yang hitam ni adalah T1. Siapa lebih tinggi dengan temperature, T1 lebih rendah daripada T2. Okay, apa yang tertinggal kat sini kita punya EA. So letaklah kat sini hujung ni 1 EA. Lepas tu buat garisan putus-putus sampailah ke puncaknya. Right, so dia suruh PSP. So kita nak tahu yang mana satu untuk energy molecule with energy greater than EA. Okay, untuk T1 dia punya dekat area yang hitam kan. Okay, so ini, so the area under the curve shaded here is the number of molecule with kinetic energy greater than EA for T1. However, untuk T2 dia kat sini pula. Okay. Baru besar. So, saya kena loretkan dari sini sampailah ke atas. Sini. So yang kali hijau tu adalah the number of molecule with kinetic energy equal or greater than EA for temperature 2. Yang berloret hitam untuk temperature 1. So sini kita label sikit. Here is number of molecules with energy greater or equal EA. EA tu apa? Activation energy. spell dengan penuh, spell out correctly. Okay, settle dekat situ. Dia suruh explain. Alah, nak buat page baru ke. Briefly explain the temperature effects towards spring. Jadi tulis kat bawah lah tadi, silap lah. So the shaded area represent number of molecules with kinetic energy equal or greater than activation energy. Okay, kemudian apa lagi? Biasalah temperature punya explanation. Bukan nota, so saya tulis apa yang saya ingat. Dalam nota ada untuk yang complete version. At higher temperature, saya buat temperature ni je, Q2. Molecules will have higher kinetic energy. Thus, more collision and effective collision occur. Conclusion electrons that's when therefore rate of reaction at T2 is higher than T1. Itulah. Okay, yang detailnya you boleh refer dalam lecture note. Saya tulis macam ni je. Kau rasa macam dah panjang dah sebenarnya ni. Okay. Alright, so itu sahaja untuk past year question bagi question number 8 until number 10. Kan, sudah je tak? Habis dah. Right. So, boleh teruskan untuk question number 9 sampai number 14. Semua dah ada dalam playlist. Should be. Okay, and good luck. See you again.